My dear student, in my today's lecture, I'm going to discuss a new topic that's called resistance on current electricity chapter 11 for the student of class 9-10. Boys and girls, I'm going to discuss about resistance. Resistance is the property of any matter which opposes electricity while electricity passing through it. It's called resistance. That means it's the electric property which can create obstacles when electricity passing through it. You know that, boys and girls, resistance are two types. Number one, fixed resistance. That means the resistance which one's value is fixed is called fixed resistance. You know that fixed resistance is normally denoted by this symbol R. In next part, variable resistance. You know that variable means the things which can vary. So the resistance which can vary is called variable resistance. And the symbol of this variable resistance is just like this, is the symbol of variable resistance. The practical uses of this variable resistance is regulator of our electric fan. Now, the unit and symbol of resistance. Boys and girls, the unit of resistance is ohm, OHM. Then symbol is this ohm, and the symbol of resistance is capital R, or it may be smaller. Now I'm going to discuss the laws of resistance. There are two laws of resistance. The first law of resistance is called law of length of resistance. The first law of resistance is called law of length of resistance. So, law of length. Resistance is directly proportional to the length of any resistance or conductor or any material. And this law is applicable at a fixed area of cross section. So, area of cross section is constant. So this is applicable for the case of a fixed or constant area of cross section based wire. So R is directly proportional to L. What does it mean? When L increases, the resistance increases. When L decreases, then resistance decreases. And this one is equation number 1. Now, the second law of resistance, and this second law is called area of cross section of the resistance. Resistance is inversely proportional to, I repeat, resistance is inversely proportional to the area of cross section. For a particular condition here, in this case, length is constant or fixed, and this is called equation number 2. So from these two laws, at first I can say that resistance is directly proportional to the length, and in second case I can say that resistance is inversely proportional to the area of cross section. So for more area of cross section, resistance decreases, and for less area of cross section, resistance increases. Now, boys and girls, I want to discuss a combination law of resistance or combined law of resistance. From equation 1 and 2, I can say that R is directly proportional to L divided by A. If I combine equation 1 and 2, then I can say that R is directly proportional to here L by A. Now I need to apply a constant term here, and that is R equal to rho into L by A. R equal to rho into L divided by A. And this rho is called specific resistance. So in short, you can say that here L is the length of the conductor or resistor, A is the area of cross section, rho is called specific resistance. This specific resistance depends on the material or medium of the conductor, and here R is the resistance. Now I'm going to discuss about specific resistance. If I say that this is equation number 3, so from equation number 3 I can say R equal to rho into L divided by A. So R into A will equal to rho into L. Now rho will equal to what? Rho will equal to here RA divided by L. Boys and girls, I am to give a definition here. Say I am to take a conductor which one's length is 1 meter, which one's area of cross section is 1 meter square, and resistance is R. Then R ohm. Then I can say that it must be R ohm meter square per meter. So in short, it is R ohm per meter. Ohm per meter. So in definition segment, I can say that the resistance of a conductor or material having initial length 1 meter and area of cross section is 1 meter square, and area of cross section is 1 meter square, is called specific resistance. And this specific resistance is normally denoted by rho, and the unit of this specific resistance is ohm meter, not per meter. This ohm meter. This specific resistance, listen to me, this specific resistance normally depends on only the material of the conductor. Now boys and girls, in next segment I am to discuss the connection or combination of resistance. There are two connection of resistance you already know from class 8. One is series connection of resistance and another is parallel connection of resistance. I am to discuss series combination of resistance here. Say this is resistance 1, this second resistance, and this is third resistance. And to connect this resistance one after another, this is the first one, R1, this is the second one, R2, this is the third one, that is R3. So when I connect this resistance just one after another, what does it mean? The last end of first resistance, is connected with the first end of second resistance, and this sequence goes on. So these resistors are connected one after another. This connection is called series connection. In series connection, I want to know what will be the equivalent resistance. So what is called equivalent resistance? If I replace these three resistance by single resistance, say if I want to replace this resistance by a single resistance that is called RS, so that total electromotive force and power of the circuit remain same, then this RS is called equivalent resistance of these three resistance R1, R2 and R3. R1, R2 and R3. Okay, so this is called equivalent resistance of these three resistance. Now I want to calculate equivalent resistance from this segment. Say, boys and girls, this three resistance is connected with a battery and a key. First one is R1, second one is R2, third one is R3. Electromotive force is E and switch is connected K. Point A, this point B, C and this point D. When I connect the switch, then this battery will produce I amount of current, and this I amount of current passing through the circuit. So when I amount of current passing through the circuit, you know that resistance is the voltage consumer. It can consume voltage. It can drop some part of voltage. So for resistance R1, voltage drop will be V1. For resistance R2, voltage drop will be V2. For resistance R3, voltage drop will be V3. So these three voltage drop indicate the total amount of electromotive force, since I'm discussing about ideal case. So in this circuit there is no internal resistance here. From my discussion I can say that electromotive force E will be equal to V1 plus V2 plus V3. I repeat, E will equal to here V1 plus V2 plus V3. Now by applying Ohm's law, E will equal to R into RS. Why RS? Because if I replace all of three resistance by a single resistance RS, then total electromotive force of the battery of the circuit and power remains same. That's why these three resistance can be replaced by RS if RS is called equivalent resistance of these three resistance. Now V1 will be equal to here I into R1 according to Ohm's law. V2 is I into R2 and V3 is I into R3. Now take a common I here, then you can say that R1, R2 and R3. In this side I into RS. So finally you can easily say that RS will equal to R1 plus R2 plus R3. This is the equivalent resistance in series connection. So when I connect some amount of resistance in series connection, then equivalent resistance will be the addition or summation of all of the resistor or resistance. Now in next segment I am to discuss the advantages of series connection. You know, boys and girls, this is a very simple circuit. You already see this. Number 2, to connect and to repair this series circuit is a very easy task. Anyone can connect this circuit and anyone can repair this circuit very easily. Number 3, it will take very small amount of wire to connect the series circuit, because this is a very simple circuit, so it will take very small amount of wire. In next step I am to discuss the disadvantages of series connection. Number 1, electric performance of electric device are not same. Say these three resistance are three electric device. For example, these three are the electric bulb. If you connect these three bulb with the battery, then I can say that electrical power of first light is maximum, second light is moderate, and third light is minimum. So their electric performance are not same. And next point, if any one of the connected device, say R1, R2, R3, is cut off, then total circuit will turn off. If any one of the connected device, that means from R1, R2 or R3, if any one is cut off, then you can easily say that the entire circuit will turn off. Say if the first one is cut off, then total circuit will be at off stage. This is the very important disadvantage of series circuit. Now I'm going to discuss about parallel connection. Parallel connection of resistance. Say these are two fixed points. These are two fixed points. I want to connect three resistance in between these two fixed points. In between these two fixed points. The first one is R1, second one is R2, and third one is R3. The first point is point A and second point is point B. This type of connection is called parallel connection. In definition segment, I can say that if all of the resistance first point are connected at a fixed point, if the first point are connected at a fixed point and last point is also connected at another fixed point and last point is also connected at another fixed point, then this circuit connection, this resistance connection is called parallel connection. And to connect this with a battery, say this is a battery, this is a battery with a key to find out the equivalent resistance. If I replace this resistance by single resistance Rp, so that total power remains same, total voltage remains same, then this Rp is called equivalent resistance. Now when I connect this switch, then this circuit will produce I amount of current. Since electromotive force and resistance are same, so this also produce I amount of current. You know that at point A there are three branches here. One is R1, R2 and R3. So electric current also divide into three parts. One is I1, another is I2, and the last one is here I3. So these are the electric current, and those divided part of current coincide at point B and flows like I amount of current inside the circuit. So from this device you can easily say that electric current will divide into three parts: I1, I2 and I3. According to Ohm's law, you can say that V equal to I into R or E equal to I into R. So if I apply E equal to I into R, then in this segment I can say that I will equal to E divided by Rp, and then I1 will equal to V divided by R. V divided by R. You know, boys and girls, in parallel connection, since there are no other resistance in the circuit, so all of the resistance will consume same amount of voltage, and it must be electromotive force. So I1 will equal to E divided by R1 plus I2 will equal to E divided by R2 plus I3 will equal to E divided by R3. I repeat, in parallel connection, since there is no other resistance rather than this parallel connection, then you can say that the voltage drop in between AB part will equal to the electromotive force. That's why I'm using here V is replaced by E. And from this connection I can say that 1 by Rp will equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equivalent resistance in parallel connection, or in short you can say that Rp will equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. This is the equivalent resistance in parallel connection. Now boys and girls, I'm going to discuss some advantages of parallel connection. Say, I'm going to draw this circuit again so that we can discuss easily. R1, R2, R3, electromotive force and key K, A point and B point. Number 1, advantages of this circuit. Electric performance of all the entire device are same because R1, R2, R3 will provide equal amount of voltage. Since they will provide same voltage, so their electrical performance are also same. Number 2, if any one of the device is cut off, or say this R1 will cut off, damaged, then you can say that no current will passing through the R1, but other device R2 and R3 remain turned on, So this is a very vital or very important advantages here. Now the disadvantages of this parallel circuit. You see boys and girls, it's a costly circuit. Why is a costly circuit? Because to connect this electric circuit, you need to take some help with some engineer, electrical engineer, or some other technical person. You cannot repair this circuit very easily, and it will take huge number of electrical wire. Number 2, to connect and repair this parallel connection is not easy task. So I discussed this already. Finally, boys and girls, your homework. Do an assignment on the basis of resistance. My entire discussion on the basis of resistance, and I want to make a summary of my lecture number 2. Firstly, after this lecture you can explain, number 1, what is called resistance. You can already know what is called resistance. Number 2, what are the two laws of resistance. Number 3, what is specific resistance. Number 4, detail about specific resistance. Number 5, connection of resistance. And number 6, comparative discussion about series and parallel circuit connection. Thank you very much. Thanks to all.